Well, good morning, ladies and gentlemen. Today we are talking about solving radical equations. And this time, instead of using an actual radical, we're going to be using rational exponents. So it's just a little extra step, nothing too complicated, but it's worked out the same way with the extra step. Well, it's actually a replacement step, but you'll see in a moment. So the first one we're going to talk about is 1,024 equals parentheses negative 2 minus 6n to the 5/3 power. All right? So the first thing we want to do is we want to make sure that there's nothing outside our parentheses, either in front or back, besides the exponent. So as you can see, there's nothing here outside of it, and there's nothing behind it. All right? So we don't have to worry about moving anything either by dividing or adding or subtracting. So from here, what we're going to do is we're going to go ahead, instead of converting this into a radical expression, we're just going to take our rational exponent and use the reciprocal of it. Remember, the reciprocal is when you flip your fraction. So instead of 5/3, it's going to be 3/5. And remember, whatever we do on one side, we have to do on the other side. So we're going to still say 3/5. So you can use, if you're using Desmos, you'll type in, have your number, you'll type in the number, and you'll say a to the b power, and that will be your number. All right? So on the left, let's go and take care of the right side first. So the 5's cancel because 5 divided by 5 is 1, and then 3 divided by 3 is 1. So that means on the right side, we're going to be left with negative 2 minus 6n. All right? Over here, you're going to have 1,024 raised to the 3/5 power. So again, I'm not doing it in decimals. I'm actually using another calculator. And I wind up with 64. So the purpose of that was basically, remember when we talked about how you convert expression with rational exponents to a radical. So we were basically looking for the 5th root of 1,024 to the 3rd power. So we went ahead and did that in Desmos, so we don't have to worry about it. So from here, it becomes a simple linear equation. So we want to get rid of the negative 2 because it's not directly touching our variable. So we're going to add 2 to both sides and get 66 equals negative 6n, because these 2's cancel. All right? So then now we want to get an n completely by itself by dividing by negative 6. So we divide both sides by negative 6, and so we want it with 66 divided by negative 6. I would say minus negative 6, sorry. Divided by negative 6, which comes out to be negative 11. And as I said, for our purposes, we won't have extraneous answers, but in future math classes, I recommend plugging the answer you get back into your original equation to see if it's, to make sure it's not an extraneous answer. All right? So the next one we're going to work on is this one. We have k to the 1/3 minus 8 equals negative 3. All right? So from here, now this time I have this negative 8 that's not a part of the k to the 1/3 expression. So we have to move that first. So we're going to do that. We're going to add 8 to both sides because the opposite of negative 8 is positive 8. And be left with k to the 1/3 equals 5. All right? So from there, we're going to do the same thing we did up there in the previous problem, where we're going to multiply by the reciprocal, or we're going to raise it to the reciprocal power. So when subtraction, like 1/3, the reciprocal is 3/1, but what's 3/1? Just 3. But I'm going to still do 3/1 just so you can see the consistency. All right? So we do that on the left side, that cancels all of my exponents and winds up with k. And on the right side, when we say 5 to the 3rd power, it's 125. All right? And so that is, again, how we solve equations with rational exponents. So thank you for your attention, and I will talk to you later.